The catch block. If a line of code within the try block causes an exception, program flow jumps to the various catch blocks. If any of them refers to an exception class matching the one that occurred, that block is executed. If you include multiple catch blocks, the order is important. You must catch subclasses before their ancestors. The finally block serves the opposite role as the catch blocks. The code within it is executed even if an execution occurs in the try block. The flow of exceptions. How long does an exception last? Until it is caught. If it is not caught, it filters up the call stack until it is caught. If it is still not caught, Java displays the message and the call stack to system.err. Try without catch. You can have a try block with a finally block, but no catch blocks. Do this when you want to perform certain cleanup code in any case, but you do not care about handling the exception. Throughout the Java library, you will find methods declared with throws case. Whenever you call a method that throws any exception other than a runtime exception, it must be caught. You can do this in one of two ways. The first method. Enclose the call in a try block that catches the exception. Second method. Amend the calling method declaration to indicate that it throws the exception. You have to note that the runtime exception and its subclasses are exempted from this requirement because they are so widespread that it would be too cumbersome to require you to catch them. Nevertheless, you will find some methods that explicitly throw a runtime exception. Often, your code will explicitly throw exceptions. They are an important part of an application's overall design. They provide an efficient, elegant way to indicate or handle runtime problems. Often, a block of code will trap an exception, only to turn around and rethrow it or throw a different exception. This will be useful when the trapping code wants to know something about the exception but isn't actually handling it. The trapped exception is different than the one to be passed to the caller. Perhaps the caller will receive the trapped exception wrapped in another, rethrowing the same exception. Sometimes you may handle an exception in a catch block but still want to deal with in a higher level. You can do so by rethrowing the exception from within the catch. If you have a finally block with a return statement, it will override any exception condition that remains, and that exception is not passed up the call stack. This is true for uncalled exception as well as exception that are explicitly rethrown. Rethrowing a different exception. More often, your code will trap one kind of exception, but throw a different one to the caller. Perhaps the exception you thrown will contain the one you trapped. You can also define your own exception classes by extending exception. These custom exceptions can represent specific runtime conditions. Of course, you will have to throw them yourself. But once thrown, they will behave just like ordinary exceptions. When you define your own exception classes, choose the ancestor carefully. Most custom exceptions will be part of the official design and thus checked, meaning they extend exception, but not runtime exceptions. Callers must catch them. If you do not want to force the caller to handle the exception, write a runtime exception subclass. If your exception is really a system problem, you might write a subclass of java.lang.error. However, callers probably will not catch such errors. The subclass is more for information than for useful handling.